This video is going to cover question 5, part A from the 2021 AP Calculus AB free response, no calculator allowed portion of the test. I cover A, B, C, and D all in their own individual videos, so if you want to see any of those other ones, other solutions, feel free to check out my other videos. All right, so let's hop into A here. A wants us to show that our derivative dy dx equals this equation right here. And they start us off with this equation over here to work from. Well, you kind of know as soon as you see x's and y's kind of mixing together, whether in your original equation up top here or in your derivative solution that they're looking for here, what you're looking at is going to be an implicit differentiation problem. So we'll go ahead and rock out some implicit differentiation and see if we can get our answer to match their answer. So 2y squared minus 6 equals y times the sine of x. When I do implicit differentiation, what I do is I wrap this equation in a set of parentheses, and I'm going to dx this equation. Whatever is on the bottom of your derivative here, that's what you're going to d whatever when it comes to this equation. My little saying when I do implicit differentiation is every time I take a derivative, I get extra stuff. And what that extra stuff is going to look like is kind of envision on that ddx, envision there being this little box up on top here. And every time you take the derivative of something, you're going to take the derivative like you normally would, and then you'll add this piece on, and you'll fill that box in with whatever the letter is you took the derivative of over dx. So let's put that into practice here. So I come through, I would take the derivative of 2y squared following my power rule, bring the power down, subtract 1 from the power, that would get me 4y. I took the derivative of a y, so I get a dy dx. Moving on down the road, the derivative of negative 6, that derivative of a constant, no matter what method you're using, is always going to be 0. So then we move on to the next side. We get our equals. And then as we come down here, we'll notice that we have two things being multiplied. Whenever you've got two things being multiplied, you know that you need to apply the product rule. So my product rule recipe goes fg prime plus gf prime. You've got to have some sort of rule that just flows out of your brain, like the back of your hands. You just got to know them so well. Product rule, quotient rule, chain rule, all those rules still apply in implicit differentiation. So when I look up here, my f piece is going to be the y, and my g piece is going to be the sine of x. And when I go find my g prime and my f prime, that's when I'm actually taking a derivative, and that's when I get my extra stuff that I was talking about. So we'll follow our rule here. The rule says first go grab f. Well, that's going to be y. Then we want to multiply it by g prime. The derivative of sine, that's a special case. We just have to have it memorized. If f of x equals the sine of x, the derivative of sine is cosine. So then the derivative of sine would be cosine. I took the derivative of an x, so I fill that box and I get a dx dx. Every time I take a derivative, I get extra stuff. Then the rule says plus, go grab the g piece, which is the sine of x, and then multiply that by f prime. The derivative of y by itself would just be 1, and then I took the derivative of a y, so I get a dy dx. At this point in the process, I do what I call just my cleanup step. You work your way through it, and you kind of put things in order based upon your rules as you do them. And sometimes it's better to rearrange things or get rid of stuff you don't need. So the next part of my process is always just what I call the cleanup step. So I get 4 dy dx equals, we'll call that y cosine of x, and then dx over dx, those are going to cancel out. That's like having 5 divided by 5. They cancel out. That's really just a 1. Then plus the sine of x, don't need that 1 anymore, and then dy dx. So the rest of the problem is really just a big algebra problem. We need to solve this equation to get dy dx by itself. That's what we're trying to solve for here. And the way you do that when you've got multiple dy dx's in a problem is you get everything that has a dy dx on one side of the equals, and everything that doesn't have a dy dx needs to move to the other side. So I'm going to start by just moving this sine x dy dx over to the other side, subtract that over here. And out of there, we'll get 4y dy dx, excuse me, minus the sine of x dy dx. And then all of that is just going to equal the y times the cosine of x. The reason that we do this is now that everybody on this one side here has a dy dx in it, you can factor a dy dx out of everybody. You can pull a dy dx to the front. So I factor my dy dx to the front, leaving me with 4y from the first term minus sine of x from the second term, and all of that still equals y times the cosine of x. Now that those two things are being multiplied over here, we can now just divide this chunk over to the other side to get dy dx by itself. So I divide over 4y minus the sine of x, and I end up with, on the left side now, just dy dx equals y times the cosine of x over 4y minus the sine of x. And there we have it. Our answer here matches up with what they wanted us to show up top here. And we're done with the problem. So this one we would have gotten 1 point for doing the implicit differentiation step. So you'd have gotten 1 point here, and then you would have gotten 1 point for working that algebra out to get all the way to the bottom. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.